All right, guys, what I want to do is finish talking about the last little bit of Chapter 5 today. I'll give you the second half of class to continue working on any of the homework from Chapter 5. And then next week, we will begin reviewing for finals. Okay. The last little bit of material that we need to cover here are some of the other types of equations that you may need to solve for. Okay, we're going to talk about three different types today. The higher order polynomials, mostly ones that are of quadratic type. Okay, that means something more than just a quadratic equation. But if you have an equation in which your highest power is 2 times the lower power, okay, then that's called an equation of quadratic type. It can still be solved using all the different methods that we've solved quadratic equations for. And the way that you're going to solve that is you're going to use what's called U-Substitution. And this is the way that U-Substitution works. You're going to take an equation, and you're going to let U equal whatever the smallest power is. You're going to take the variable to that power. So here, x to the 4th is exactly twice the power of x squared. So we're going to let u equal the smaller one, x squared. And by doing that, what it allows you to do is it allows you to replace this middle term with u. And then x to the 4th in terms of u would be u squared. So this is why it winds up being called of quadratic type, because you can substitute a u in for x squared, or whatever the smaller power is, and turn it directly into a quadratic equation, which you'll then solve using any method that you have for solving a quadratic. Okay? And so of these methods, what could you factor this black equation into? All right, so if you treat this as a quadratic equation, our binomial factors have first terms of u. The last terms have to have a product of negative 20 and a sum of negative 8. So what factors of negative 20 have a sum of negative 8? Negative 10 and positive 2. And so what you can then do is say that u is equal to 10, u is equal to negative 2. And you can go back now after you use this u substitution, and you can plug the x squared or whatever you substituted back in. So now you get that x squared is equal to 10, x squared is equal to negative 2. And so when you work to solve this, you then use any other method that you have for solving the quadratic. So here we can extract the square root. X is equal to plus or minus the root of 10. And here x squared is equal to negative 2. Is that even possible? No. So this becomes extraneous. It's not going to give you a solution in the real number system. And so your answers would be plus or minus root 10. Okay. All right, see if you can do this problem just very quickly. Again, it's based on exactly the same set of rules. And see if you can find the solutions for x, please. All right, once again, we have a higher power that's exactly twice the lower power. So we can let u equal x squared, and then just plug that in. So we get a u squared minus 5u minus 36 is equal to 0. Again, look to see are there binomial factors. What two factors of negative 36 have a sum of negative 5? Negative 9, positive 4. And so when you set these equal, you get u is equal to negative 4, or u is equal to 9, and then just substitute in. So x squared equals negative 4, x squared equals 9. Again, you can't have a perfect square that equals a negative, so you can discard this set. Extracting the square root would be the best way to solve, taking into consideration the positive and negative root of 9. And so plus or minus 3 give you your solutions. Okay. All right, now this works anytime you have a higher power that's twice the lower power. So here's an example that would extend this. Okay, so if you're given this equation, is one power double the other? Is 2/3 double 1/3? Yes. So that means this fits the quadratic type model. And so you can use U-substitution. So if we let U equal the smaller power, x to the 1/3, what we can now do is we can rewrite this as U squared minus U. Let's move the 6 over. So we write it in standard form at the same time. And then look to factor. Are there two factors of -6 whose sum is a -1? -3, +2 would be your factors. And so we get U is equal to 3 or U is equal to -2. Once we find the solution for U, we can plug back in. We get x to the 1/3 is equal to each of these values. And now we can solve it. How do you think we would solve an equation to isolate x if we have a power of 1/3? How do you undo the cube root? In order to get an x alone on the left side, we're going to take both sides of this equation to the power of 3. So just undo this power, leaving an x is equal to 3 cubed, which is 27. And then we do the same thing here, cube both sides. Is that even possible? Can the cube root of a number equal a negative? Yeah, index is odd number. It can equal a positive or a negative. And so when we solve this, we get x is equal to -2 cubed, which is -8.